Okay, so we're into week 11. We're going to be finishing off game engine today. I'm going to probably break it up into two parts. This would be part one. And last week we kind of talked about how the game engine worked. So we outlined, if I go back to the GameEngine.py framework here that Andy Harris has built up for us. And if you notice, again, 2006. And yet it's not a bad little piece of code that he's put together. On the right, again, if you look at the outline, there are tons and tons of different classes that he's written. Well, tons and tons. Super Sprite, the scene, the label, the button, the scroller, the multi-label. And the main ones that I would really want to know if I was using Game Engine for your final project would be the scene. Right? The scene class kind of incorporates all the stuff that we were doing in our main function in previous iterations. For example, mail pilot, we were using our main function as the control function, and in there we would call different methods for our screens, right? Or different functions, sorry, they're not methods, in our screens, so that way we can move from our start screen to our game screen and then back to our end screen, right? That would be mail pilot. But in this particular case, the scenes are actually the screens, and you can create your game framework within it. So if I click on the scene, if you notice, just to review, right, again, you have all the requirements, all the components that you need in Pygame to set up your screen. So here we go. Here's your screen, which is a top-level window. This is the I portion of your idea framework. The idea and the alter framework are in here inside the scene class. That's what they've done. So they've created this blueprint of this class for your scenes, which is a good thing. So you don't have to repeat yourself if you're creating new screens, if you will. Right? So again, here's we're initiating Pygame. We're basically saying the Windows 640 by 480. Now, one thing I would change here from a game engine perspective, if I was going to do it, to make the scene more flexible, I think, is to actually, this set mode, I would ask to, maybe you want to set the resolution somewhere on the scene. So inside the constructor here, I would actually probably modify this, the game engine, to include kind of the resolution of the scene, right? Because maybe you want control of that. Maybe not every game is going to be 640 by 480 for you, right? So you may want to do that. The other thing to do is to reset the mode. You can do it, instead of doing it in the class, you can change this or override this within your code. But I think it's slicker, and again, it makes it more for a robust class when you create objects that are more, there's more control or parameters that you can add into the objects themselves. So again, the scene, right, is an object, right? This is interesting because the scene itself is not a subclass of any other class. It is a class unto its own, right? So here's the object, right? And the object, this as an object, this is almost like our base, our super class would be the object class. So what we're doing here is we're saying we can override this class. We inherit all of the methods from the super class called object, right? Then what we're doing here is we're incorporating, like I said, the initialization portion of the framework. We're actually creating a sample sprite. So if, for example, and this is all the stuff we need for our demo. So if we were going to demo our game engine, this is the portion of the scene class that you could remove, right? So example would be, well, guess what? We don't have initially a sprite. Well, the scene class will create a sprite for you, and it's going to create this demo sprite called sample sprite, and it's going to be of a type super sprite, right, which is part of this whole framework, and it's going to set an initial speed and angle and all that kind of stuff to this sample sprite, and it's going to add it into this group, right? And then there's a start method, a stop method, and so on. So you could actually create a small piece of code to test out the game engine, and that's what this scene class allows you to do by already creating some basic elements, right? But again, if I was going to rewrite this or create this scene class, or let's say you want to take a portion of this game engine like we talked about, and you wanted to use some successful classes that are written here and use it in your own code or create your own game engine, then perhaps you wouldn't want to use the sample sprite that's in here because it's only a demo. So a little bit of lines you could clean up. The other thing is the background fill starts off at 000. You could override that with your, your class. If you were to create a class object called scene, and if you were to override or inherit the scene class, create a subclass of the scene class as an example, and you wanted to override some of the backgrounds and so on, you could do that as well, or you could make it so that you can decide that the class has more parameters that it can take, so you can change the fill of the background if you wished. Okay. So that's what it does. And again, it incorporates the main loop. And if you notice, the construct here is double underscore main loop. And this is kind of saying class that is private that you can override. Okay. So that's really just a quick review of the game engine. So today what we're doing is if we shift back to our presentation, we've already used a couple of elements. We've talked about labels and buttons and so on. But basically, we also have some other graphical widgets that we can use. So let's take a look at these. Okay. So again, we have these different objects here: a label, a button, a scroller, and a multi-line text. Multi-line text is cool because in previous iterations, if you noticed, we did in MailPilot, we had that whole instruction screen, right? And the instruction screen was just like one line after the other of text that we would kind of space out to create the illusion of multi-lines, right? But here we actually have a multi-line text label that we can use that's part of our game engine. So let's take a look at that. I'm going to load up GUI demo ge.py. So here it is. And again, here, if I was going to review the class and the objects, I'm going to keep doing this again. I know this is the last day we have of teaching, our last official teaching day, but I want to go over some of the same objects again and again with you, because the more often you see these things, the more we talk about them, the more they will make sense, the more you see them, right? So here's another little piece of code here. So we got our game class, which again, I am inheriting from the game engine scene. I'm actually, passing in the game engine scene class into my game. Okay? So my class game is what I'm calling it. And it's basically what I'm saying is it's the game class is a subclass of the game engine scene class. So instead of scene, we're calling it game. That's all it is. Okay? What we're doing also is we're calling the constructor from the original, the parent class, which is the game engine scene class, the scene class, right? We're filling the background with 000. Now you could have done this in different ways. If you notice, it's red and green all turned up, right? And if red and green together make what color? Yellow. Yellow. And if you notice that the blue is turned off, right, in this particular case. The background should be, like you said, probably yellow. Then what we're doing is we're calling a few methods right inside the constructor. We're calling the add labels method, the add button method, the add scroller method, the add multi-label method, and we're actually taking all those buttons and titles and scrollers and everything in multi, and we're combining them into a sprites group. That's what we're doing here. So here's the add labels method. The add labels method actually uses the game engine label as its basis, right? We assign the text, game engine GUI demo, and we put the position and the size. So this is a great example of how to use labels right here inside of our, with game engine. So game engine, you've got all the classes that are ready to go for you, as opposed for you to create them from scratch. You don't have to do that here. It's all made, so you can kind of use these things. So a couple labels that we create. One is called label title. The other one is just called label, a regular label. And you define different parameters for these things. We've also defined a specific font called Goodfoot for the regular label. We added a button, right? So here's our button. It's a label button. That's what we call it. And we make it so that the button itself is I have a label for it as well as the button. So here's our button, add button, right? And it says, don't click me. That's what the text says on the button, right? We add a scroller, we add a multi-label in the same way. And if you notice, the multi-label has a bunch of text lines, and the text lines are in a list, right? So that's what the text lines are, and it's a multi-label class that we are instantiating into this multi-variable, right? So a bunch of lines, right? And then on update, after we've kind of have all these different objects, which we define, we add here. We add all the different objects, right? We add them into our sprite group right here. And on the update, right, what we're doing is we're saying, look, if my button is clicked, then say ouch, and fill the background with black. So the background's going to shift from yellow to black. We're going to blit that background onto, we're going to blit the background, which is black, onto the screen at 0, 0. So we're going to actually recreate the background and blit it onto the screen. And then what we're going to do is we're going to basically add the value of our scroller, whatever the scroller is, to the center of the label scroller. We're going to talk about that in a bit. And then the only thing that the main has inside of it here is game is equal to game. So we're instantiating the game method, or the game class, right? We're saying here's our scene, right? And we're starting it. We're starting the game, right? Now if you notice, or if you remember, in our game engine, when we start the game, it's also automatically has, the event handlers is listening for our X button on the top level window, right? So we don't have to do any of that. It's already written for us, and it's in the background, okay? So I click the button, right, as an example, but if you notice, right, every update, if the button is not clicked, as an example, what happens? Well, it stays black, right? I've clicked my button and it goes to black, but there's nothing that I see here that resets the button back to normal, right? The button, or the background to normal color, right? So unless I'm mistaken, once you've clicked it once, and this, you don't call the constructor more than once, so the buttons don't get reset. There is no reset function here, or method, right? So let's see what happens when I run it. So here's our, our GUI demo, right? And I click the button that says don't click me, and it turns to black, right? But I can't get it back to yellow because there is no function to remove it or put it back. If I click my scroller, and again, both of these little pieces are missing, I actually move my scroller left and right depending on which position I want it to go in. And there's a limit, maximum 250, which is right here, right? I say, well, I'm going to go to 250. So from wherever the value is to 250. That's all I can go to. So I'll go back. So I can't go, I can go low. I can keep going off the screen, right, to 0. But I can't go higher than 250. It says 250 is our max. Right, that's part of our scroller, right? So ouch, here's our label, here's another label, and here's the multi-label. And if you notice, the game engine GUI demo, it's kind of weird. It's kind of, all these labels are kind of, have the text kind of higher up. So I'm not sure if that's an effect. I don't know if you guys are getting the same thing. Can you check? It could be the type of text we're using or the effect that the author wanted, but my guess is it might be an effect of generations of Python code that's been changed. And I think the original intent was for your text to be centered in your label. No, it looks like you guys have the same issue. So
Is the multi-line like an array?
it's a list.
You have to call each line?
Yes, because it's a list. Here it is. So multi-line is an array. So you have each text line is part of a list. So for example, this would be the 0th element. Right, and so on. This would be the first element, the second element, and so on inside the array.
If you wanted lots of text, or you could just put it all in one.
You could.
Call sections of that.
You could, but probably you'd want to create another label, as an example, because it doesn't take much to create your own multi-label, and then use that, put it in there. Once you've instantiated it once, you're done. Right, you don't have to worry about it again. You can always hide it and show it again or whatever. Right. And that's something that some people do. They have their instructions. You click on a button, and the instructions are hidden. They're physically there. You've instantiated the object, and now you display the object. And then when you click it again, or you click off it, or the X on that particular piece of instruction, it goes away. because you don't need to see it all the time, right? Some people have for instructions, and just this is an aside for project number 1A, they've used different other methods. They use a movie. Some people have recorded a movie, like how to play your game. That's a neat idea, right? Where they've recorded themselves, let's say, with something like this, like Open Broadcaster that I use here for our broadcast to YouTube. Or other game capture, screen capture kind of methods, and they create their movie and they incorporate the movie into Vigan. Now, we're not covering how to do movies, but if you look online, you can figure out how to display a movie in your startup, which is kind of neat. Okay, so really that's what this piece of code does. It creates all these different constructs that we're talking about, these widgets that are part of the game engine framework. And again, and this is a great reference. This presentation is a good reference where it has a lot of the properties for all of the GUIs, the widgets that we have here. So a lot of these public attributes, like for example, font, text, and foreground color, and so on, all these things are public attributes of the class for the labels, right? And then they talk about here how to build a label, which we've kind of already done. I'm going to leave this to you to look at. But basically, it creates a label and how to do this. And the button attributes are here. So here's your font, your text, your foreground color, and so on. So again, I'm just going to skip by these some of these things. Active and clicked, you can actually for buttons, you can kind of if it's true, if the mouse button is down and the mouse is over the button, as an example, this is kind of cool. Clicked is if the button was clicked. You can actually have a couple of these. You can create event listeners for the button that detect whether if it's active or clicked. Then we talked about how to create a button. And the same thing with the scroller attributes, how to do the font for the scroller, the size of the scroller, and so on. And then here's position of the label center used to position an entire label. And this is kind of cool because I think this is where it does an X and Y position, the center of the actual label itself, and the font for the scroller, because the scroller is almost like a subclass of the label class. You create a label class, and then you create a scroller, which actually incorporates this label. Okay. And it talks about how to make a scroller. Okay. And again, our increment value here, our maximum value for the scroller is 250, and our minimum value is 0. That's part of our, and that's why it doesn't allow you to go greater or lower. And again, these are just GUI widgets that you can use for your game if you needed something like that. Scroll up or scroll down, those kind of things. Okay. And again, I'm not going to talk too much about this. Multi-label, same thing, just like you said. It's a list of different lines of text that you display. Okay. And now we're going into the super sprite. So this is kind of cool because once you create the super sprite, again, there's some primary methods. So again, it handles basic setup and movement. There's vector manipulation, so actually create where the next position of your super sprite is going to be. And there's some utility methods like checking collisions and setting some certain behaviors and comparing your super sprite with other objects. So I think that's really the breakdown or an overview of the super sprite class itself. And here, if you look at it again in detail, and if you were going to write your own classes, and as I said this before last week, I would want you to create some kind of a reference card for all of your classes just like this, where each of your methods, and whether they're primary or secondary, are really described and documented well. So this is how to use your super sprites. If you wanted to use your super sprite for your game, it's pretty well documented here how it works. Okay, and I'm just going to pass through some of this stuff. Same through with your vector methods, what the vectors do for delta x and delta y values, what these methods allow you to do with the sprite. And if you notice, let's look at just the one. So set dx, and then it says delta x is a new delta x value that you're actually setting, and it changes the delta x attribute of the sprite, and use this method instead of directly assigning a delta x value. So basically, these are your setter methods. In other languages, you call them your setter methods. So these are public methods to allow you to modify your sprite, and it's the proper way to do it from a best practice perspective when you create a class. Okay. And this is really true too, this line here. Sometimes you do need more sophisticated control. So what you can do is you can create a subclass of your super sprite class to create additional methods that your super sprite doesn't include, and that's fine. And I think instead of using a basic sprite, if you were going to write a class, and if it's already written for you here in your game engine, nothing's wrong with using creating a sprite, which is a subclass. Sprite class, a subclass of the super sprite class that's part of the game engine, and creating a more complex super sprite, if you will. Okay, and I'm not going to go over this. We've kind of gone over this with over the last lesson or so. But again, these check events and check bounds and so on, part of the presentation. And again, you guys have the presentation you can look at as a reference. So again, let's look at one. So the check events method, this utility method, you have to overwrite this method to add code that will run in each frame. So basically, what you're doing here is you're checking the events, and this is where usually, like it says here, event or collision handling code. So this is where you do it in this check events method. So this is one you would override or write again, basically, when you create your subclass. Here's an example of an adventure game. And this is going to harken back to our original Dragon.py game. Remember that? Way back, we wrote this Dragon.py, and it was like, turn left, turn right, these kind of things. And some people actually wrote some really good ones. Other people wrote some really boring ones that I had to mark, right? But, it's okay, right? This one, Adventure.py, is another way of doing a similar thing. Now, we're doing it in Pygame, so now there's going to be a graphical element to it as opposed to just simply a text-based game. Okay, so let's take a look. And this uses the game engine. So here's adventure.py. And let's look at it a bit. So again, I'm doing a couple things. I'm importing Pygame, I'm importing game engine, and we'll just take a pause after this for a break. I'm creating something called a node class. The node class is a subclass of the superclass object, which basically is, it's just saying, I am a class. It's an object, right? In my constructor, and here's where, in my opinion, you have a very flexible class that we're creating, right? It's a node class. It's taking the title, the description, text, okay, index, so A text and B text, and A index and B index, which allow you to kind of go back and forth. Where are you, right? And then we're saying this. We're creating our class variables. Title is equal to title because we're creating references for all these parameters that we're taking into our class, right? A text, and so on, right? So that's all we're doing with our node. All our node does is we create almost like a structure for our title, our description, and so on. And each of the nodes is where you would say turn left or turn right, like as an example. And the text for the node, there might be some description of one text or the other, and we're going to see how this works. Here's our game screen, and our game screen is just a subclass of the scene superclass, right? We have a label, and basically we create a label called, which is a subclass, or sorry, an instantiated object of the label class from the game engine library, right? We're using the same Goodfoot font, 50 points, that's quite large, right? The description is a multi-label. That's what we're doing here. All right, so this label description, multi-label, and we're also making it it's part of the Goodfoot TrueType font that we're using. 30 points, it's quite big again on our screen. Setting the background color for the label, the center, and so on. We're creating two buttons, button A and button B, right? And the first button is a standard game engine button, right, as an example, and so is the second one. Okay, so we got two buttons. And then what we're doing is we're creating a sprite group with our title, the description, button A, and button B. And we're filling the background right now with what looks like a funky color that's red, green, and a little bit of blue. Okay? So a very dark color. We have a method called loadNode, right? LoadNode, actually, it needs to accept something called node, right? Node is part of our parameter that passes in here. Now, if you notice, back up here, we've created a node object, right? Here, we haven't instantiated a node object yet. But load node is a method. So for example, we create our game screen, and in our method, GameScreen.loadNode, we have to pass a node in here. And the node, we're going to say, whatever the node title is, we're going to pass in. It's a container that we're going to use, that we're going to pass in the text of our title. The description is going to be passed into our class, and everything else. Okay, the button A text, button B text is our A text and B text. So for example, turn left, turn right for the buttons, right, and, as an example. And we're also passing a couple of indexes, which we don't know what they are yet, index A and index B. On update, what we're going to do is say, if the first button is clicked, well, guess what? Our self.A index is equal to -1. Okay, so we're choosing -1. And then self.keepGoing is equal to false, right? Oh, sorry, if we're checking, we're saying if our index is set to -1, then we stop the game. Okay? Else, self.loadNode, here we go, this load node, right? And we're going to load in this something called a node list with an A index that's going to be passed into that node list. Okay? So the index of the node list, whatever the node is that you're at right now. Okay? And the same thing goes with the button B. It's exactly the same, right? All it gives you is two options, option A or option B, whichever option you choose. Okay, let's take a look at the main function. So here we go. We have node 0, node 1, node 2, node 3, node 4, node 5, node 6, node 7, node 8, 9, 10, 11, 12, 13. There's 13 nodes, and there's also an empty node that we can use. Okay, so a bunch of nodes in here in this list, if you noticed, right? And we have something called node list dot append. We create something, an object called node list, and all the node list is a big list. That's all we're doing here. This is our main. Okay, and then in the node list itself, we append the first node. We append the second node, and so on. We append all the nodes as part of the list. And if you notice, the list has it's a list within a list, right? The first part of the list actually is here's on a burning ship. The second part of the list, let's take a look at this, inside of our node class is the second piece of our node, which is the description, right? The third part of the list is two possibilities, either put out the fire or jump, right? So those are two possibilities. And then you have our choices, our node 1 or node 2, okay? Node 1 or node 2. In our node 1, right, it says basically we sync. As you pour the water on the flames, you sync, and then you say start over or quit the game. If you start over, it takes you back to node 0, which is right here. If you quit the game, now your object is, your index is -1, and if you notice here, if the index is -1, your keep going loop is equal to false, right? So really the first node, you only have one choice, okay? If you choose put out the fire, right, as an example, if you put out the fire and it goes to the first node, then you're going to sink. As you put the pour water on the fire, you're going to sink. That's the first problem. Really, the right choice would be to jump. Okay, that's the first thing. If you jump, it takes you to node number 2, and now you're in the water. That's the title of your node. Huh? I'm just telling you how it works, right? So we can see how it is. I'm not trying to cheat, right? So really, that's the adventure game in a nutshell, right? So you've got all your nodes, as an example, right? And that's all that I need to do from a node. I basically use this whole construct from here all the way up to the top to load up my node list array. Okay, that's what I'm doing. I'm actually constructing my node list, and my node list is a list of nodes. Here's my node, and again, I define node up here as a construct. This is the container for all this stuff, to hold the text and label A and label B for my buttons and so on, and the index. So where do I go from here? Index A would be my choice A. Index B would be my choice B. And depending on which choice I chose, that's the next node that I'm going to go to. So quite very, a little bit cleaner in terms of code. So you could have written, without a graphic user interface, if you wanted to, you could use these same classes to write your Dragon.py game, okay, theoretically.
So you
accept that for Project 1.
No. I wouldn't accept it for Project 1, no. It's too boring. Anyways, but as you go down here, now we actually do the construction of the game itself. So we say, well, our game is equal to game stream, which is actually a subclass of the scene class. And then what we're saying is game.nodelist is equal to nodelist. We're actually passing in or making a reference of the node list into our game class. Once I've done that, I say, well, I load the nodes from the first node in our list, right? I'm referencing the first node of our list. I'm loading that into the first node. That's our first node. That's our starting position. I can choose whatever starting position I want. I can load the node from whatever that list position I want. So let's say node 5. I can start us there, right? And it's perfectly fine to do that. And we'll try that out later on. Our caption is going to be called Island Adventure, and we're going to start the game. Okay, let's try it out. So here we are. We're on a burning ship. Your vacation is going fine, except you wake up to find your ship is on fire, right? This is our cruise ship is on fire, okay? Do you attempt to fight the fire or jump overboard? Okay, back to Dragon.py, right? I know. Put out the fire. I know it is awful. It's hard to read. And or jump. So I know put out the fire is going to end us. So let's just jump. So we go to jump. Now we're in the water. Okay, you find yourself in the water. You see a lifeboat nearby and some debris floating off in the distance. Which do you swim toward? And again, we're going from one node to the other here, right? So again, probably lifeboat would be an index of 2 or 3 or whatever, and this would be 4. I'm guessing here. Okay, so lifeboat or debris? Debris. Okay. On shore. The floating debris keeps you afloat until you drift to a tiny island. You are exhausted. Do you rest to rebuild your strength or try to start a fire?
Well, I've already gone through it, so, but I
okay.
think build fire is actually pretty
Build a
clever.
fire. All right.
I thought it was clever.
You're trying unsuccessfully to build a fire. Keep trying or start over? If I put keep trying, it doesn't really do anything for me because I'm just here. Start over. Start over, I'm on a burning ship. So I keep basically trying to build a fire for the whole time and my game's over, which is kind of weird, right?
Well, I think it's just supposed to say, like, no matter how hard you try, if you keep trying, you're never
It's not going to start the fire, yeah. So you're not going to start the fire. So again, it's a classic, choose your own adventure with 2 choices. I mean, and again, just to show you how it works, if I was to put in an index of 5, like I said in here, and start the game now, right? So I'm loading instead of loading the first index, I've started off, and now I'm rested, right? Instead of starting off with, I'm on the burning ship. You feel well rested, now you must decide what to do next. Build that fire or start exploring the island. We know the fire is bad, right? Let's explore the island, right? So supplies. As you explore the island, you discover secret crates of supplies, or several crates. I'm trying to read this bloody font. That drifted from the ship before it sank. You now have the tools to build a shelter or go hunting. Which will you do first? I like hunting. Forget the shelter, right? Go hunting. There's a wild pig. What do I do with it? I tackle the wild pig. Well, you miss the pig and it disappears into the jungle. Do I chase it? Yes, I do because I'm crazy. And if you notice, I can't chase the pig. So I can return back to my supplies. My supplies are gone. I can start over or quit, and I quit the game. Right? So again, I mean, I think it's choose your own adventure, but it's using a class structure for this, and we're doing it within Pygame and with a graphical user interface. Kind of neat.
Graphical user interface, that font.
Yeah, it's pretty crappy with the font. All right. Almost. Give me a few more minutes. We'll break in a second. We're almost done this thing. So if you notice, here's the nodes that I talked about before. So this is we're revisiting like day number 1 when we were here. We're talking about our first project, our first assignment here. And if you notice, this is the way that it's written, right? So here's our game overview, and I kind of brought that to you way back before, right? And a lot of this, in some ways, this is a really good example of mapping out your game. Now this is not the pyramid that I drew, right? This is a non-linear way of doing stuff. And if you notice, there are some loops. Like if you can keep building your fire as much as you want, here's that loop. I'm continually building my fire, and it's going to keep doing that forever. I can keep building it until I decide not to, and then I can go back, right? And if you notice, it also tells me how to win the game. It says, well, there's two ways. I could drown from the ship, or I could be rescued, right? Those are the two opportunities. So, you know, and if you notice, I lose here too. The supplies are gone, I lose, right? So here's another lose scenario. Here's a third lose scenario. It's too crowded, right? So I'm in the boat, there's lifeboat, debris, it's too crowded, I lose. I sink, because I stay on the ship and try to fight the fire. So 1, 2, you know, I think this is kind of a lose too. Let's keep trying.
Yeah.
Just kind of, so 1, 2, 3 maybe, you know, 4, this whole thing is a lose. This whole wild pig thing is a big it's a big, you know, you're chasing something as a ghost. You're never going to find it, right? It's kind of a lose scenario, and you can't go back for your supplies because they're gone, right? So that's really, you know, an overview of the game itself. Okay, so to me, I mean, even though we're doing game nodes, this is a great way to write your stories too, right? So I'm not going to go over the game list. We've kind of already gone on there. I'm going to do one more before we break for lunch, or break for break, coffee and so on. You can tell, yeah, I know. You can tell my brain is I need coffee, right? But anyways, the great way, what we've done here is, even though I've created these nodes, we're looking at these nodes, you can create some similar things when it comes to your game world, right? So for example, you have your first level. On your first level, you have some choices you can make. You can fight the boss monster, as an example of that first level, or you can try and escape and go around the boss monster. And if you fight the boss monster, it might take you to level 4, or level, you know, whatever it's called. So you don't have to make it linear, level 1, level 2, level 3. You could go to different levels that you create. You could create a multi-level game. I've only asked you for 3 levels, right, because of the time factor. But in a real scenario, you can create multiple levels to make the game more interesting for your users, where they have other options. So you can, if you go up, as an example, you leave the screen and you go up, then you go to another level. And that level will represent a different level of conflict. You go back down, and depending on how you program stuff, as an example, maybe that when you go down, your ship goes down, your avatar travels downwards, towards the bottom of the screen. Maybe you're going to get another level that's going to load up, as opposed to just left and right scrolling, right? You know, there's other ways of doing things. Okay, let's look at the lander. So it makes it easy to build this type of game because it has the Super Sprite class, and we're just going to add gravity. Okay, so let's take a look at this. So the lander, and then we're going to pause for intermission. Right. So here's our lander.py game, right? And again, the lander is a Super Sprite. That's all we're doing. We're adding a thrust initially at 0.1, so it's already moving, right? A side thrust of 0.5, so there's a forward thrust and a side thrust. We're going to figure that out. An angle of 90, which means it's pointing right up at the time, right? Because 0 is to the right, 45 is to the top right, and 90 is up, straight up, okay? And initially, the lander is in flight. It's true, right? We're going to check keys with our check events function, or check key, and we're going to do, in our check keys method, we're listening for our up button, our up arrow, our left arrow, and our right arrow, but we don't have a down arrow, because we don't really care. We don't want a lander to crash, right? So we only have a up and a right and left. And they do different things. We're going to update the vector. Yes, I know. And we have our little platform. Our little platform is also a sprite, right? And our platform doesn't move, but it appears in different positions on the screen. That's what it does, okay? And then we have our game. And our game basically says lunar lander, arrow key to begin, right? So we're listening for the arrow key to start the game, okay? We add the gravity. So our gravity, which is set to, if you notice up here, on our lunar lander, there is no gravity that we've set, right? But here, we're saying our gravity for the game is 0.02, which is, that's how slow it started to drop towards the, you know, our the base of the screen. It's going to continue to accelerate the gravity every frame, so it's going to continue to fall until you counteract your DY position. Okay. We're checking the lander, and depending if you get right on the position, if you're within a certain parameter, you're going to say nice landing. Else, you're going to say too much vertical velocity. And then there's other different messages it's going to have, like must approach from the top, going too fast to the left, going too fast to the right, and so on. let's take a look and see how this
It's really not.
ugly game works. All right, so we're starting to fall, if you notice, right? I'm going to start the game with our thing. Here we go. And we're going to keep falling until we fall to the screen. So something like that happen. Whoop. I'm going to keep going. And it's going to keep doing that forever. So to me, this is bad. Like, I would probably make it so you fall off the screen, well then, you know what? You die, right? For the game. I'm going to give it some different kinds of thrusts. So I'm thrusting towards the game. And I'm going to try and get on the actual, change my DY.
Are the controls opposite?
Yes. Oh, nice landing. And if you notice, nice landing is actually showing us here our landing on the console. And it's going to keep saying nice landing because we have a collision. All this is doing is detecting a collision between the console and the actual lander. So it stops the collision right at the console. It's almost like this classic platformer action that we're doing. So how do we do that? Well, we make our collision. This is the key thing here. What we want to do is detect the lander that collides with the platform. And all we're saying is if the lander it does collide with the platform, if that's true, then we say if the lander dx and is less than 0.5, so the dx value, right, the change in x and so on, then we can say nice landing, right? So all we're doing is checking if the lander dy value is greater than or equal to 0. So if our lander has stopped moving, we're gonna say that that's true. We're checking to see if there's a collision, and we're also checking to see if our dx and dy values are all are good. If they're not, then you know it's going to basically here. If we do collide with the platform, here's our collision. We're checking, and we say our dx and dy values stop. So once we've collided with our platform, we set our dx and dy values to 0, no matter what happens, which means, right? And we're updating the vector and so forth. And we also stop the flight, make it false. Okay, which means if I run this again, okay, this is the funky thing now, and now the platform is in a different position. So I'm going to come at the platform from the bottom, right? I also stop. As soon as I touch my platform, I stop from the bottom because I've collided with the platform. So what's the problem here? I can't really change position anymore, and I can't go up. I can go through the platform if I keep pushing. Look, I'm actually pushing my lander through the platform because I'm still colliding with the platform. So now I'm above the platform. Here we are. Oops. And now when I land back onto it, I stop. And I don't go through the platform. So the challenge here is, do I do two things? Do I create another sprite that's underneath the platform? So when I hit that sprite, as a collision perspective, from a collision perspective, right? Do I check to see if, well, there's different methodologies here, right? If I'm hitting the bottom or the top, I've collided, but which part of my sprite has collided? Is it the top that's collided? Is it the bottom that's collided? Which part? And that's what you want to check whenever you do your platformer. You want to say, well, if the bottom of my sprite collides with the top of my platform, there's a collision. But I need this type of collision to happen. So the bottom of my sprite with the top of the platform. Is that true? Yes? Good. If it's not true, and somehow there's another collision, right, then you've got to create another behavior, like maybe bounce off, right? Don't, bounce down off the platform or die, create an explosion or something, right? So there's other behavior we can check. But this is like, I'm glad they did this because it shows you one method of creating this platforming effect. There's many other ways, and we'll talk about them as well. Okay, and again, this kind of shows us the different ways to do this. Asteroids, we've kind of went into this already. The one change I made, and I kind of talked about it at the beginning of this class, and I'll show it to you again, and I'm going to just kill this presentation. When we come back, we'll do the second part. But if you look at the asteroids game, it's kind of neat, but I've modified it for our class. I've created, I've used that other ship. I didn't like the ship that the asteroids came with, so I've modified my ship, so I want to use that kind of ship that gives me the thrust and so on. There it is, right? So here's my modified asteroids game, right? And if you notice, there's some collisions, but now I have the sprites to make the ship look a lot neater, right? You can try doing this yourself too as an exercise for today if you want, or we can work on your project number 1A. But if you notice, it's a little bit better, and if I fire the space bar, I still get these bullets that come out of the ship, right? Again, almost a fully, yes, it is an odd angle. You have to kind of figure out the bullets a little better. The bullets, in my opinion, are probably the weak part of this whole game. Yeah. Yeah, depending on the angle. If I change my angle too rapidly, like for example, I fire and I go like this, fire, fire, right? There's some behavior that needs to be modified here.
So that was like my side, the last process, when if you shot and then move your guy forward, you could be in front of your bullet.
Which is bad, right? If your bullet has to actually be a little bit better than that. So that's it for this first part. We're going to hook back for the second part after our